Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. Today we are gonna be looking at binary codes and mainly how they are found, written and converted to decimals, and from decimals that's what we are gonna be actually mainly looking at. And so we want to start with how actually they are written. So they use a formation of 8421. As you can see, I have written there on your screen. They use a formation of 8421s mainly to write them. This is actually how the formation works. The first way is actually to write a 1 where the decimal number appears in the formations. Like an example for 1, you can see in the formation of 8421, 1 appear in this column, so we have written 1 there. You can see in the for 2, as the for 2 in the formation appears in this column, so we have written 1 here and written zeros in all the other columns. As well as for 1, you can see the others we have written zeros. Now for the others, like 3, we actually write 1s into columns in which the numbers in the formation add up to the decimal number. For example, for 3, you can see in the formation we have 2 plus 1, which is equals to the same to this 3. So we actually write 1 on the 2 and 1 on the 1, so that they can add up to 3, and on the rest we write zeros. So that's how we write them. You can see for 4, because there is a 4 in the formation, we just write 1 in the 4 column and zeros in the rest. For 5, you can see we write of course 1 in the 4 column and 1 in the 1 column, so that 1 plus 4 may add up to this 5. So we continue like that. And actually for 6, you can see in the 4 column we have written 1, and in the 2's column, so that 2 plus 4 it may add up to 6. For 7, we have written 1 in the 4 column, 1 in the 2 column, and 1 in the 1 column, so that 1 plus 4 plus 2 it may add up to 7. And for 8, because there is an 8 in the formation, in the 8421 formation, we have just written a 1 in the 8 column and the zeros in the rest. For 9, we have just written 1 in the 8 column and 1 in the 1 column and zeros on the rest. So that's how we actually write binary codes. We always use these formations. In other names, they are called the BCD. So mainly in egg questions, they actually ask either you convert the BCD to decimals or you convert the decimals to BCD. I actually find it to be one of the simplest units, because all you're gonna do is just compare. A good example is here, where you are told to convert the decimal to BCD. Of course, you have been given 17 as a decimal. Base 10 means it's in decimal. So what you want to do when you're given such a number to convert into BCD, you just want to divide it. Since we don't have a binary code for the whole 17, so we just take 1 and we find the binary code for 1. You can see here is 0, 0, 0, 1, and we just take 7 and we find for 7, which is 0, 1, 1, 1, and we just come here and write 0, 0, 0, 1, which is for 1, we combine with that one of 7, which is 0 1 1 1, and we get the BCD for 17. So basically, the other questions in which you asked is to convert the BCD now back to decimals. So you can see where you are given such a number. Of course, I told you whenever there is a binary included, and mainly you are dealing with ones and zeros, it's always advisable to start counting from your right, because as you can see here, the binary codes are actually into 4 bits. So which means we're gonna divide them into 4, like you saw for the 17. We had for 1 we had 4 bits, and for 7 we had 4 bits. So in order to go back, we have to have each and every section with 4 bits. So we start counting from the right. We're gonna have 1 2 3 and 4. So we come here and divide, and on this side we're gonna have just 1. So we can't work with this one as it is. We're gonna have to make it into 4 bits, and as I have explained earlier before in other videos like binary conversions, you can check the video out. The link is in the description. We just add zeros into your left so that we can make it into 4 bits. So we will have 0 0 1, that's for the first section, and 0 1 0 0 for the second section. So there are 2 ways in which you can know in the numbers represented by these bits. One of them is, if you have a table, you just come here and compare, and you see which bits match that one, and you can see here is for 1, and then you look for 0 1 0 0, and you can see here is for 4. The second one is that you want to count from your right to acquire the powers, and you're gonna have 0 1 2 3. So basically, because these are zeros, you can just assume them, and you will have this as 2 power 0. So you will just have 1 times 2 is power 0, which is equals to 1, since 2 to power 0 is 1. And you can have for the second section, it will be 0 1 2. So you have the power 1 with the power of 2, so it will just be 1 times 2 base of binary to power 2, which is equals to 4. So you just have your BCD, your decimal as 14. So for more understanding reasons, let's take another example. I find it here that it's a bit difficult. So we're gonna convert the following BCD to decimal. Of course, you can see you are given the number in binary codes. So as I have said, you want to start counting from your right, since the binary codes are grouped into 4 bits. So you count 1 2 3 4 and divide, and then you're gonna have 3 on this side. So you can't work with 3, so you just have to make them into 4 bits, and I have said you just add a 0 onto your left, so that you will have 0 1 1 0 1 0 0 in your first section, and for the second section you will have 1 0 0 1. So you will come here. As I have said, there are 2 ways in which you just can acquire the decimal numbers for each section. One is, if you have already drawn a binary code table, you just come and compare, like here you can see is for 4, and here 1 0 0 you can see is for 9. So, or the second way is which you count to acquire the powers using the base of the binary. So for the first method, we have just seen is for 4 and 9, meaning which is 49. And for the second, to acquire the 49, we just count 1 0 1 3 1 2. So you will have 1 times 2 is power 2 is equals to 4. And for the second section, we will have 0, which means we will have 1 times 2 is power 0, 1 2 3, which means we will have 1 times 2 is power 3 plus 1 times 2 is power 0, which basically is just 8 plus 1, which is equals to 9. So we will have 49 as our decimal. Thank you. Just hit the subscribe button and the bell icon, so that you may get notified when we post more contents on mathematical solution. Thank you. I will see you on another video.